Hey everyone, let's talk about position and frames of reference and what physicists mean when they say that. So position and reference frames, speed and distance and time don't require us to define where we started and where we ended up. They just measure how far we traveled and how long it took us to travel that far. However, much of physics is about knowing where something is and how its position changes with time. To define position, we have to use a reference frame. A reference frame lets us find where an object is located relative to other objects. For instance, we can use a map to compare the location of different cities, or a globe to compare the location of different continents. However, not every reference frame is appropriate for every problem. So, interesting that there's a picture of the globe here, because the globe is spinning, the Earth is in orbit around the Sun, and the whole solar system is moving in one of the spiral arms of the Milky Way galaxy, and all the galaxies are moving away from each other. So we're actually moving a lot, but relative to the surface of the Earth, we don't appear to move very much at all unless, we're traveling. So whether we sense if we're moving or not, or whether it's important to us, really depends on what reference frame we're going by. If we're looking at the frame of reference of what the galaxy is doing, we may actually be moving quite a bit. If we're just seated watching the video, then we're not really moving very much or at all relative to our frame of reference, which is the surface of the Earth. So reference frame activity, we did one of these in class where you guys had to come up with a set of instructions for someone to find an item hidden in the room. Okay, so one group had to provide the directions, the other group had to use the directions to find the item. So this is one example of such an activity. Send a volunteer out of the classroom to wait for further instructions. Place an object somewhere in the classroom. Write specific directions for someone to be able to locate the object. Write them in a way that allows you to hand them to someone who can then follow them to the object. Remember, you can't tell them the name of something your object is near, just how they have to move to get to it. For instance, walk to the smartboard, which would be good directions if I had one, is not a specific direction. Test your directions out on your classmate, who is hopefully still in the hallway. Okay, so we want a starting point, we want directions, and we want a finishing point. So we want initial position, we want to know final position, and maybe in the middle is our set of directions. Okay? So in your groups, you made a list of the things you need to include in your directions in order to successfully locate the object in the room. And I think we discussed the findings, and it was pretty interesting that even though the groups who didn't know where the objects were tasked with following directions to find the objects, that very nearly every group found the object from the first group's directions. So it was pretty interesting that both groups actually understood the frame of reference. You probably found that you needed a starting point. That's our initial position. A set of directions. So we might call that our displacement, right? A distance and a direction in which to go from our starting point in order to get to our final position. And also a unit of measure, right? You guys are required to use units to get full credit on an assessment, and that's because time time, if we specify it, seconds is different than months, right? They're not the same thing, and they're very, very different quantities, and they mean different things. So if it's just a number, you know, who knows what that means? In this course, we'll usually define the origin as a location labeled 0, create 3 perpendicular axes, we'll probably stick to 1 usually, and use the meter as our unit of measure of distance. We'll be solving problems in 1 dimension. Typically we use the x-axis for that direction. Positive will be to the right, negative will be to the left. We might also say that positive is east, negative is west, positive is north, negative is south. We could define it the opposite way, but unless specified, this is what we'll assume. We also can think about compass directions in terms of positive, negative, for example, north, positive, south, negative. The symbol for position is x. Think of the number line, right? So if that's the origin of the number line, you might go in the positive direction, in the negative direction, or any combination. All of the following are examples of positive direction except the compass point of west, left, or negative on the horizontal number line. All of the following are examples of negative direction except, well, to the right, positive, or east would all equally be positive, so that would not be an example of a negative direction. Okay, so I hope that helps everybody understand position and frame of reference a whole lot better. Okay, see you next time.